All right, here we go. So 1.1 homework. For the first problem, all you're doing is dividing that. So if I do 26 divided by 11, that's 2.3636 repeating, right? So this is what I see, and that is rational. So the idea is that you just go through each one and you figure out, is it going to be rational or is it going to be irrational? Okay? I think that one maybe we should look at is possibly E and G. So for E and G, when there is a number, Okay, when there's a number in front of the radical, this means multiply. So you're doing 2 times the square root of 100. So this part you guys should know. What's the square root of 100? 10. So you're doing 2 times 10. 20. And is that rational or irrational? Rational. Okay, but this one, again, I'm going to do the square root of 39. So on your calculator, this is the button we use for square root right here. It's next to division. So you put in 39, then you click that, and we get 6.24 ... So that is what 39 square root is, right? But what do you do with that number? Times by 5. So multiply 5 equals still irrational. Okay, still irrational. So I'm going to write that right here. That was letter G. So irrational. Did I spell that wrong? Irrational. Yes, okay, we're good. Okay. All right, now, example or problem 2. Which one on this side, or which ones? Gavin?
B and C.
Okay, so for this one, I would say you guys should know this. Square root of 4. 2. Minus 1 point, well, 1/3 is what?
0.33.
Right, it's repeating, right? So how I would show that into the calculator, it's a rational minus an irrational, which is going to be, rational minus irrational, because it's repeating, is going to be rational. But to show that, I would do 2 minus 1 point, and then I'm going to put 3s until I cannot put any more 3s. So hit equals, and look, it's 0.6 repeating, right? No. If it's repeating, it's rational with an R.
But how come there's a 7 at the end? Well, it will probably be...
It rounded up. It rounds up. Huh?
And it will probably separate that in it's because it has to round.
Oh, yeah. It would, yeah. Okay, so that would be 0.6 repeating, which became rational. Okay, one thing, what was your other question? C? Okay, so we'll do that one too. And then this one, I'm just going to show you. Look right here. You know that 1/2 is 0.5, so I just made it 7.5 minus pi. Do not use 3.14. Use pi. So right here on the calculator, you see it has the pi symbol right there? So on is clear, 7.5 minus, click pi, and then hit equals. Good job. You have to click equals. So is that rational or irrational?
Irrational.
Right. No. Okay. For letter C, for this one, you need to multiply the outside numbers. So you would multiply 4 and 2, and what do you get? 8. Then you multiply the insides.
21.
And now this problem is like what we did over here, right? So you do the square root of 21, and then you multiply it to 8. So you remember, you do 21, click the square root x, then times 8 equals.
36.66.
But is that repeating?
No.
No. Look at the whole number. It's not repeating. So what is that? Okay. Should we do D? Okay. Just do the square root of 14 and then add 9.7 to it.
Irrational.
Yes, it's going to be irrational.
Perfect triangle.
Yeah, it's not a perfect square. It's not going to come out nicely. Okay, now, the bottom part is just a whole bunch of other problems like that. So 45 divided by 3, you literally calculate that. What do you get?
Rational number.
Rational. But if something is rational, it is also a real. Now, you guys can use X's or you guys can use a check mark. I don't care. Okay, any other problem on this grid here that you want me to do? This one?
Yeah.
Okay, and then what was your question? The pi one. Okay, so pi, that is 3.14, etc., right? It's going on forever. So what is that? Which is also real. Now, this one, you would divide these first. So what's negative 28 divided by 7? Negative 4. That's still inside the radical. So then I would say, yeah, it's going to be imaginary because that's going to be 2, right? Square root of 4 is 2. But the negative makes I. Yep. Man, you guys listen to me. Inside the radical is imaginary. Good job, guys. That makes me proud. All right. Anything else on this page? Okay, flip. The top here is just more of the same. So anything on here that you feel like you need to ask about? Yes, Gavin? Third to last. Okay, this one? Okay, so I would still do division first here. We get what?
2.
Yep. Yep. Okay, even though the square root of 2 is like an irrational number, right? That negative on the inside is still going to make it an I. So it's still going to be imaginary. Okay? Anything else? Okay, let me ask you this. I'm going to ask you this. For that first problem, this right here, what would you guys put into your calculator first? Like, what would you do to solve it?
You would find the square roots of the set.
I would do this one first. Then I would times that by 2. And then I would add the square root of 7. Do you want me to do that with you in a calculator?
Yes.
Okay. Yeses and nos. All right, so here we go. I'm going to start with the square root of 7. And you get a decimal, 2.6, etc. You times 2, hit equals 5.29, okay, plus 7 square root, but you have to hit equals. And you get 7.93, ... So it is, yep, irrational and real. And then for this one, do that pi button. Do 11 times the pi button. Okay, number 5. Yes. Yes. Okay, so number 5. Do you remember in class last time we talked about a lot of things, right? But one thing we talked about was opposites. What were opposites? So if I said to you 5, what's the opposite of 5? Negative 5. And 5 minus 5 makes what? 0. So what they're really wanting to know is which one here are opposites. What makes a 0 here?
The square root of 10 is irrational. It's not 5.
D.
Right. It's D. But yeah, so you're saying, okay, so it's saying which shows the set of irrational numbers under addition is not closed. Not closed means like, let me tell you what closed means. So if I said an integer plus an integer, it has to equal an integer. If it's an integer plus an integer and it doesn't equal an integer, it's not closed. Okay? So that's irrational.
But could we put this in like some notes, like what closed means?
Yes, we can do that. Can you remind me to do that?
Yeah.
Can you be in charge of reminding me that? So this is an irrational, and if you're subtracting an irrational, I get 0. Is 0 irrational?
Yeah.
No, it's rational. So it's not closed because it's not like this minus this is the same thing. It's different. It's a different category. So D is the answer because it's 0. Now, 6, 7, 8. We have to do these. Now, they're not hard because you guys should know what perimeter is now, don't you? You add all sides, right? So, you just got to read it. Find the perimeter of a rectangle if the length is 4.6 inches and the width is 6.5 inches. So, you draw a rectangle. What would you label this side?
6.5. Oh, no, 4.6.
Yeah, it's the length. I know the length is smaller here, but yeah. So length, this is your width, and you got to add all the sides. Am I adding two numbers?
No.
Wait, why is your width the one that goes down and your length the one that goes across?
It's just usually because length is longer. I think of like length longer. I know that the numbers are not matching up with that idea, but just do length as the longer one. Okay, so if I add the two numbers, is that enough? No, I got to add how many numbers? Yes, good job. That's exactly right. You could totally do that. So we could add all of them up, or you could do like 4.6 times 2, and then add that to 6.5 times 2. So can you guys add them all up, or do your multiplication? And what did you guys get? 22.2? That is what I should have gotten. Okay, there we go. Okay, yeah. So this is, it's like a, you know, application problems are? Like real world problems?
Yeah.
Yeah. So there's like a real world problem. So like if I have like the concept of perimeter, do you remember the concept of perimeter? Yes, hopefully. Adding all sides. Okay. But then in the lesson yesterday it's asking, is the perimeter rational or irrational? So is this rational or irrational?
Rational.
Rational because it terminates, it stops, right?
Yeah.
Okay. So, is it Kylie? Kaylee? What's your question? Yes. You guys said rational? Okay. Is that your question too? Okay. And it is Tamia? Yeah. Okay. Okay. Kaylee? Elijah? Well, I don't think you guys are going to the same restroom, so it's okay. And then Tamia. That's really sloppy. I'm so sorry. Okay. All right, moving on. Number 7. I think you guys could do this by hand. Yes. Right? Or, I mean, you can use your calculator. Can you solve it without me? Yeah. Finding the perimeter. You're just going to do what?
Add them all up.
You got it. Add them all up. And then get your solution and decide, is that going to be rational or irrational? Yep. Yes. Okay, now, the bottom one, are we ready for that? This one is just like what we did in the very first thing about the bridge deck, okay? A sailboat has a large sail in the shape of a right triangle. The height of the sail is 17, which, what kind of number is that? Yeah, it's a rational number. The height of the sail is rational. Okay, the width measures 8 yards. Again, is that rational or irrational? And can you find this diagonal length? C. What are we going to use, people?
We got to use,
Yes, Pythagorean theorem. So we're going to say 8 squared plus 17 squared equals, and can you solve it? Can you square it? Can you add it? Can you square root it?
I don't know.
Let's try it. Use your calculator. 8 times 8, 17 times 17.
46.
Are we on the right track with me? Okay. What'd you guys do next? All right. Okay, it says, is the length of the diagonal a rational or irrational number? Irrational. Okay, so those were not too bad once we got into them, right? And we've talked about some of that now. So, who needs a little bit more time on this? Because you got to go back and finish things.
I got 8.
Okay, let's do this. If you are done with it, you're good. Your name's on the front. Pass it back, and I'll collect it from the people in the back. If you need more time, I understand. We didn't have a chance to go over it last time. So you need to finish it up. You either can turn it into me at the end of the period or when I see you on Tuesday. Okay?